Alright, so this is the second part. So like where we stop, we'll go to raster calculator. From the previous part, you must have reclassified your data, so you should have the biomass reclass, you have the road reclass, you have the slope reclass. So with those three, you can just enter the formula, this exact formula. But be very careful that and ensure that you've named your files exactly as I have done mine. So with this, you just click on OK. It will run, then you save what you get as weighted results. That weighted result is the file I have here. You should get something like this, something that looks just like this, something that looks just like this exactly. So after you get your weighted results, next thing is to add urban and mask to it. So you go back to raster calculator, and your urban mask, ensure that it has been reclassified as 0 for non-urban and 1 as urban. What I mean is your urban mask, after you've downloaded it from Google Engine, should look like this, something like let me remove this weighted results. Okay, sure, this is how it looks like. But as you can see, the values are 0, then this is like a continuous thing. So you reclassify it, go to reclassify, put urban marks, then put a 0 as non-urban, then 1 has urban, which is what I have here. See, it is 0 purple, that's parts that are not urban, and 1, the parts that are urban. See it in green. So from there, if you have that already, next thing is to just simply okay, where's my search bar? Next thing is to go back to raster calculator and set the constraints. Let me like this. This is the exact formula you should use. So that will be my urban max. Please ensure that these scripts are named exactly like this if you want to use this exact formulas, or you can just change the name to whatever it is that you used to name in your own. Then weighted results. So basically what we're trying to do here is to remove all the places that are classified as urban from that weighted results that we generated. So once you have like this, just click on run, then it goes, you would have something that I think I named final suitability. Yes, should be this. So this is what you're going to generate, something that looks like that. So basically we are, let me see, we are nearly done. We are more than 60% done already. We are still following. So from this final suitability map, you then reclassify it, take this into the reclassified. So of course select 5 classes. So that 5 classes, this is what we have, suitability class. So you start, the list is very low suitability, low stability, moderately stability, high stability, and very high. From the reclassification of this, that is how we got the suitability class. Then from the suitability class, we want to extract the best locations for citing a biomass plant. So how do we do that? We go to, why is my search running away? We go to raster calculator again, then you enter following formula con suitability class. or whatever it is you named it on your side. Then set it to 5,1. So yeah, you run this, it's going to generate a raster that would be the best. So the output from there, you should name it best sites, which is how we got this particular raster. So these are optimal sites to site your plant biomass, and as I told you earlier, it's quite a lot. And the reason why it's a lot is because our road file is quite dense. So there's a lot of straight roads, all those small irrelevant roads are there. So optimally, we should exclude most of the road. We should not have it as dense as this, but for the purpose of this demonstration, we're just going to go with that. So these are the best sites. So in order to generate the exact points in coordinates, we have to convert, like as you can see, this is a raster data, so we have to convert this best sites rather to a polygon, and we do that by using something called raster to polygon. Raster to polygon. So you just click on it, you enter the raster sites, this, and then click on run. Then you name what you got and what you get as best sites polygon. They are basically the same thing, but this one is a polygon while this one is a raster dot. So with the polygon now, we can simply just go to feature to points, features to points, so that we can extract exact coordinates for those points. So feature to points, you just select best sites polygon and click on one. So it give us this file, this file like this. So these are plausible location where we can cite biomass plants in the southwest. How many are there? There's 1,519 possible locations that we can use, and for each location we can derive their coordinate system, the coordinates. Yeah, but I'm coming to identify. So that concludes for that objective. Just trying to get something. As you can see, we have the coordinate system here. There is in decimal decrease. So when we use on our statistics, we should be able to extract the, but I don't think that's, we are not interested in that. So basically at this stage, you're done, and just at this point, are the positions where you can cite plants based on road network, based on the fact that it is excluded from urban centers, based on the fact that it is not on very elevated or inaccessible locations, based on height and stuff like that. So those are the three constraints that we used. So but for more robust research, we would usually use more, water availability, water, electricity, power grid, protected areas. There will be a lot. So that would reduce and keep on reducing it. You would have very, very small and optimal plant site. But for your stage, I think this is enough. So with that, we have concluded this. Thank you very much. God bless you.